want to look at what it means to be a function in several variables. While I'll predominantly deal with 2 or sometimes 3 variables, we can use as many as we want. A function in 2 variables is a rule that assigns every ordered pair in some set D, known as the domain, exactly one real number. A function in 1 variable inputs a single number and assigns exactly one real number as the output. Functions in 2 variables will input 2 numbers and output a single number. As an example, the function f of xy can be 3x plus 7y cubed minus cosine xy. This will be a function in 2 variables. And as I said, we can expand this to higher variables. A function in 3 variables would input 3 variables, x, y, and z, and output a real number. In this case, my function is x to the 4th plus 9xz plus ln of y. The domain of the function are valid input pairs, valid input xy coordinates. So if I have a function like f of xy equal to x cubed minus y, I can input any pair xy into this function and still get a real number out. So in this case, my domain would be all of R2, which is how we denote the two-dimensional plane. I can take any input in the two-dimensional plane, any point in the two-dimensional plane, plug it into this function, and get a real number output. If I think about the function f of xy equal to the square root of x squared plus y squared, in this case, since I'm squaring x and squaring y, I know that the thing underneath that square root will always be greater than or equal to 0. And I can always take the square root of a number greater than or equal to 0. So the domain of this will also be all of R2. If I consider the function f of xy equal to 3xy over x squared minus y squared, we know we can't divide by 0. So my domain needs x squared minus y squared not equal to 0. Or x squared not equal to y squared. And we can write this as y not equal to plus or minus x. So I can use any inputs as long as y is not equal to plus or minus x. So I can't use inputs like 2, 2, 3, 3, 4, 4, or things like 1, negative 1, 2, negative 2, 3, negative 3, things like that.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.